Hello students. So previous class we देखले electric potential at a point due to the dipole in general position and in also special case. आज देखिए electric potential energy. Electric potential energy. Electric potential energy. Hello. So what is the electric potential energy? Yes, the electric potential means the amount of work done to bring a unit positive charge from infinite to that point. Per unit charge. It is electric potential energy. It is the amount of work done. It is the amount of work done. Yes. It is the amount of work done to bring or to move a charge, not a unit charge, to move a charge from infinite to a point, in an electric field, yes. Hello. So it is the potential. It is the electric potential energy at a point in an electric field. Clear? It is electric potential energy on a point charge. On a point charge. Hello. Electric potential energy on a point charge. It is the amount of work done to move a point charge, but to move the charge from infinite to a point in an electric field. So suppose this is a point P. आमे कौन करिवा गोटे चार्ज. This is a charge Q को आमे कौन करिवा 820 के आनिवा. तो how much work is done? That is equal to W. तो लेठी P को आने ले. Where P is the एठी कौन अछि? V is the potential at this point due to a source charge. Let it be एठी के Q. So how much work is done? So लिखिवा suppose W be the work done. W be the work done to move a charge Q, to move a charge Q from infinite to a point to a point P. Now in an electric field of Q, in an electric field of Q, where the potential is V, where the potential is V. So what is the let suppose W be the work done to move the charge Q from infinite to that point, infinite to a point in an electric field of Q, where the potential is V. So if there is a source charge Q and it creates a field around it, within its field P is a point, and at the point the potential is V, and a charge ame kon kariba infinite to koti ganwa to V ko aniba. So how much work is done? So we know that by potential difference ame kon jani chhe hala. So आज V is equal to kete jani chhe W by Q. So that implies W is equal to kete gala V into Q. So this work जति कार्य है, that work is stored as energy, that is known as the potential energy. कोठी on the charge Q तल जते बेले आमे 880 के आनी के चार्ज ता थइबा सते बेले जति वर्क डन हला सेटाला potential energy on charge Q तलते. So potential energy on charge q, the potential energy on charge q. ताले q charge there केते potential energy रहला ना u is equal to, we can write u is equal to केते गेला ना v into q हला. तो so the potential energy on the charge q is equal to w, that is the amount of work done, that is equal to vq हला. तो जदि गोटे चार्ज को आमे कौन करबा इनफाइनाइट गोटे पॉइंट को आनिबा where the potential is v, तबे how much work is done, that work is stored in the form of a energy एवं जहा को आमे कोसे इलेक्ट्रिक पोटेंशियल एनर्जी on the charge q. क्लियर. एबे देखिबा what is the electric potential energy on a system of charge. एडाला on a point charge. एबे देखिबा on a system, on a system of charges, on a system of charges, what is the electric potential? The electric potential energy on a system of charge, देखो, it is the amount of work done to move the charges, to move the charges from infinite to the respective position, from infinite to their respective position, to their respective positions, clear, to their respective positions in an electric field, to make the system, to make the system. So it is the amount of work done to move the charges from infinite to their respective position in an electric field to make the system. So it is जति work done है, that work done is known as electric potential energy on a system of charge. Clear? Suppose we are interested, suppose these are the number of charges q1, q2, q3. हलानी आमे कौन करिबा, आमे ताकु गुनी ए बडे बडे जगह रखिबा. तले प्रथमे कोन अछंदी, they are at infinite, one after another आमे गोटे आनी कोन करिबा थोइबा. तले how much work is done, suppose आमे q1 को आनी के एठी a रे थोइबी, q2 को आनी के b रे थोइबी, q3 को आनी के c रे थोइबी. तले केते वर्क डन हला, जति कि टोटल वर्क डन हला सेटा हला सिस्टम रो पोटेंशियल एनर्जी हला. जदि हम लिख परिबा suppose हला, त w1, w2, w3 हला be the work done, to bring the charges, कोठो ना q1, q2, q3, to bring the charges q1, q2, q3 from infinite to their respective positions, to their respective position, to make the system, तले देन कोन हबो, तबे तले टोटल वर्क डन केते गेला, तले टोटल वर्क डन is equal to केते गेला w1, w2, w3. Clear? So this work done is stored in the form of energy. तले में कौन कहबा, तले potential energy on the system, the potential energy on the system, not on a charge, on the system. तले कौन लिखिबा, तले potential energy on the system, yes, potential energy on the system. तले u is equal to केते गेला ना w1, w2 plus w3, like that हला. So in this way we can find out the potential energy on a system. Clear? तो बर्तन देखिए in a special case, the how much, what is the potential energy on a system of 2 point charges? Hela, a system माने कौन? What do you mean by system? The system means it consists, it contains, hela, one or a number of point charges. This is the system. Hela, तो आमे बर्तन देखिबा how much, what is the potential energy on a system that consists of 2 point charges, अर्थात system of 2 point charge, है potential energy on a system of 2 point charges. Clear? The potential energy on a system of 2 point charges, on a system of 2 point charges. आमे गोटे सिस्टम तैयारी करिवा जो थरे कि दुईटा चार्ज ही रहिबो. Suppose we consider a system. This is at A, the charge मानेकर Q1 is placed at A, and this एटाला A रे रहिला मानेकर, and out a charge को रहिला मानेकर Q2 एठी रहिला हला. तले आमे एई भली गुटे सिस्टम तैयारी करिवा. तले व्हाट इज द पोटेंशियल एनर्जी on the system, on this system? हला, this system consists of 2 point charges Q1 and Q2. So suppose the position of the Q1, let it be, हला, तले एटा केतेला, तले this is your position vector, let it be एटा केतेला R1. Then this is the position of the point P, R2, हला, R2. तल this is the, एटा कौन है गला, तल this is equal to R2 vector minus of R1 vector mod. This is the distance between A and B. In this way, अर्थात we make a system like this. Suppose A and B are the 2 points separated by a distance that is equal to एतिकी. We can write, आको में लिखि परिवा R2 1 vector, let it be, है ना, R2 1 vector, अर्थात this is with respect to this 2 vector minus of 1 vector, है ना. So now consider a system. Now consider a system of 2 point charges, 2 point charges, so that 2 point charges, so that the position vector of the point Q1, so that the position vector so that position vector कह रहा हूँ of Q1, the position vector of Q1 कितना R1 vector, then position vector of Q2, let it be R2 vector. Clear? So it is position vector of R1 and position vector of R2. So what is the distance from A to B? Yes, we can write R1 vector. Then the position vector of B with respect to A. So position vector of B with respect to A. This can be written as R21, R21, and this is called to R2 vector minus of R1 vector. So what is the distance between them? The distance between them, but separation between them, that separation between them, magnitude kete gala, R21, separation between the R21 is equal to mod of R2 vector minus of R1 vector. Clear? This is the separation between this. आमे बर्तन एई भली भाव रे गोटे सिस्टम तयारी करिवा. सपोज मु एठी गोटे चार्ज आनी रहली, एठी गोटे चार्ज आनी रखले. सपोज दे आर सेपरेटेड बाय ए डिस्टेंस ऑफ मानेकर 10 सेंटीमीटर. तो यही भली गोटे सिस्टम तैयारी करिवा पाई हाउ मच वर्क इज डन केते कार्य हला प्रथम बाहर करिवा तो केमति बाहर करिवा इनिशियली हमें कौन करिवा let this q1 and q2 are at infinite initially q1 और q2 कोठे अछि infinite रे तो here there is no charge this is the position of q1 this is the position of q2 what guys to make the system to bring the charge from infinite to their respective position this is the position of q1 and this is the position of q2 तले प्रथमे हमें कौन करिवा to make the system the initially let all the charges of the system are at infinite and bring them one after another to their respective position to make the system then find the total work done suppose all the charges q1 and q2 are infinite initially q1 and q2 are at infinite Hello? No charge is here in this region no charge is there तो हमें कौन करिवा first we bring the charge q1 infinite to point A Hello? तो how much work is done तो work done to bring the charge q1 from infinite to A तो how much work is done हमें बाहर फिर से जानी छे सपोज गोटे पॉइंट चार्ज को हमें कौन कले कौन करिवा पॉइंट चार्ज q को आनी कोठो इनफाइनाइट रु गोटे पॉइंट वेयर द फील्ड इज 0 सॉरी वेयर द फील्ड इज v तल केते पोटेंशियल इज v तन जदी पोटेंशियल जदी v थिबो एवं से जगह को हमें गोटे चार्ज ता इनफाइनाइट रु आनीबा तल वर्क डन केते कहिथिले vq तल प्रथमे देखिबा व्हाट इज द पोटेंशियल एट पॉइंट a as there is no charge हला all the charges at infinite there is no charge there is no field then what is the potential at A and B the potential at A and B are 0 jehetu there is no charge initially q1 q2 are at infinite then potential in that time but the potential at A and B are 0 and B are 0 जेहेतु there is no field no charge no field no potential जेहेतु fields are at infinite तेणु initially q1 and q2 are at infinite the potential at A and B are 0 now bring the charge suppose हमें q1 को आनिले A रे रखिबा नचेत q2 आनि कि B रे रखिबा जा कर माने कर हला now bring the charge q1 to A how much work is done w1 work done to yes to bring the charge the work done to bring the charge from charge q1 from infinite to its respective position to A तले एटा होची q1 लो पोजीशन हमें कौन करिवा वर्क डन टू ब्रिंग द चार्ज q1 फ्रॉम इनफाइनाइट टू A तले हाउ मच वर्क इज डन w1 तले w1 इज इक्वल टू कौन लिखले vq व्हाट इज द पोटेंशियल एट पॉइंट A ना 0 तले 0 इनटू q1 तले दैट इज इक्वल टू केते गेला 0 अर्थात नो वर्क इज डन टू ब्रिंग द चार्ज q1 फ्रॉम इनफाइनाइट टू A क्लियर काहे कहलानी because before the q1 there is no charge if there is no charge there is no field if there is no field there is no field intensity no electric potential तेणु हमर कोन बाला to bring the charge q1 from infinite to point A w1 केते गेला 0 हला तो एबे बर्तन देखो एठी कोन आसी गला चार्ज q1 आसी गला यस एटा चार्ज q1 आसी गला तले बर्तमान b रे कोन सृष्टि हो पोटेंशियल कारण b इज इन द फील्ड ऑफ A तले आज but due to the charge q1 the field at B केता हो yes due to the charge q1 the potential at B the potential at B हैला the potential at B comma तले VB केते गेला is equal to केते हो So this is a point charge. It is at a distance r12 from this. So the potential at point B, Vb is equal to 1 by 4 pi epsilon 0 Q. Q at a source charge Q1 divided by R K, this distance. So R21 vector magnitude. Clear? We know the potential at a point to a point charge is 1 by 4 pi epsilon 0 Q by V, Q by R. So 1 by 4 pi epsilon 0 Q Q1, R to the distance. Clear? So we can write 1 by 4 pi epsilon 0 Q1 divided by R2 vector minus of R1 vector mod. Clear? So this is the potential at point B due to the charge Q1. Now, आमे ठीक कौन कर से Q1 नहीं ऐसे ठीक है अब अच्छी क्या है Q2 का नहीं कोड थी बात in the respective position Q1 का में ठीक नहीं थिले तले in the respective position है ना तले Q1 पढ़े ची और रिलेट किए Q2 तले Q2 आनी गेट थी बात तले how much work is done है ना तले work done to bring the charge Q2 from infinite to point B तले क्या था तले work done to bring the charge go to charge Q2. The work done to bring the charge Q2 from infinite to point B. Infinite to point B. तले कौन है गला? तले W2. Yes. W2 is equal to what? तले B रा में रखिले तले फॉर्मूला कौन V into Q तले V at B into कहाँ कौन होचे Q2. This is the work done. तले VB कितने भरसी? Now 1 by 4 pi epsilon Q1 divided by R2 vector minus of R1 vector mod into Q2. Bas this is the work done. So the work done to bring the charge Q2 from infinite to B after Q1. Q1 थुई साइला परे आमे बर्तन B रे जितले Q2 आनी रहिबा केते वर्क डन हलते कि yes our system is complete total charge पड़ेगा no is here all the two charges are at their respective position our system is completed then total work done केते हला to make the system clear then total work done to make the system तले total work done to make the system total work done to make the system W is equal to कितने गला ना W1 plus W2 yes the W1 that is the amount of work done to move the charge Q1 to position A कितने बार चला 0 W2 that is the move the charge Q2 from infinite to the respective position B after A after Q1 कितने बार चला 1 by 4 pi epsilon 0 Q1 Q2 divided by R2 vector minus of R1 vector mod yes so this is equal to कितना ला 1 by 4 pi epsilon 0 Q1 Q2 divided by R2 vector minus of R1 vector mod so this is the total work done to make the system the total work done to make the system is the potential energy of the system so potential energy on the system potential energy on the system of two point charges of 2 point charges the potential energy on the system of 2 point charges तो क्या देखेगा W is equal to क्या देखेगा 1 by 4 pi epsilon 0 yes Q1 Q2 divided by R2 vector minus of R1 vector mod clear so this is the potential energy of a system of 2 point charges clear बुझेला next तो ये गला हमारा potential energy of a system of 2 point charges and the potential energy on a point charge. एबे देखिबा kinetic energy. Kinetic energy on a point charge. हला तो kinetic energy on a point charge of a point charge. Kinetic energy of a point charge. हला तो kinetic energy of a point charge. तले गोटे point charge ର kinetic energy केते? What do you mean by kinetic energy? ना if a charge is in motion, जदि charge टा motion अछि तले हमें कोन कहबा? It possesses the kinetic energy. If the charge is at a position, एठी हमें कोन मारतले? At the position, potential energy. कारण हमर energy हमें दुई प्रकार जानि छे. गोटे ला potential energy which is due to the position or configuration of the system, and another one is the kinetic energy which is due to the motion of the charge, motion of the body. Suppose we consider this is a electrode, this is another electrode. Hala, we connect a battery here. Hala, if we connect a battery here, hala, so this is your positive potential, this is the negative potential. Yes, and the potential difference between this to this, let it be V. This is the V potential difference. Arthat, if the potential difference between the 2 points, but between the 2 electrodes, you can say 2 points, data point bhitere ba data electrode bhitere potential difference kete achi V. So jodi ethi ame gote charge ku rakhiba, suppose if we place here a positive charge q, tale kon haba? It repel the charge and moves towards the negative. Because this is the it is accelerated towards the negative and acquires a velocity v when it reaches the electrode, negative electrode. Tale manekar mass kete achi m. Hala, tale when the charge q reaches at this point and it acquires a velocity kete v, then what is the kinetic energy of the charge? Now this kinetic energy is equal to kete? Half mv square. So suppose a point charge plus q. Hala, suppose a point charge plus q moves from positive to negative electrodes. Positive to negative electrodes in a potential difference of V. Suppose V is the velocity acquired by the charge when it reaches at P. If V be the velocity but the charge is accelerated towards the quadrant, because V potential difference, there is an electric field, and due to this electric field the charge is accelerated towards negative plate. Due to the electric field, the charge q accelerates towards accelerates towards negative plate, or negative towards negative. Due to the electric field the charge q accelerates towards negative, and suppose v is the velocity of the charge. If v is the velocity acquired by the charge, so if v is the velocity of the charge, if v be the velocity of the charge, then what is the kinetic energy? The kinetic energy is equal to half mv square, where m is mass of charge. Clear? Mass of charge. So charge accelerates अर्थात it increase the velocity, and when it reaches the negative plate it acquires the velocity v, then the kinetic energy is equal to हाफ एम भि स्क्वायर क्लियर तल चार्ज बर्तन कोठ आसला एठे ठीक गला तल एठे दी तले गला तल व्हाट इज द पोटेंशियल वर्क डन VQ तल द वर्क डन कते गला VQ एठी कते थिला एनर्जी आमे ती देखिबा वर्क एनर्जी अनुसार एठी एनर्जी कते काइनेटिक एनर्जी 0 कारण इट इज द चार्ज इज हियर 0 एठी काइनेटिक एनर्जी कते गला यस हाफ एम भि स्क्वायर तल व्हाट इज द चेंज इन काइनेटिक एनर्जी द चेंज इन काइनेटिक एनर्जी कते गला हाफ एम भि स्क्वायर माइनस ऑफ कते गला 0 तल चेंज इन काइनेटिक एनर्जी कते गला हाफ एम भि स्क्वायर तल चेंज इन काइनेटिक एनर्जी चेंज इन काइनेटिक एनर्जी कते गला तले हाफ एम भि स्क्वायर माइनस ऑफ 0 that is equal to कते गला हाफ एम भि स्क्वायर this is the change in kinetic energy at this position the speed is 0 and then when it reaches at this point v potential velocity कते गला v then the kinetic energy at this point is 0 kinetic energy at this point गला हाफ एम भि स्क्वायर clear तले kinetic energy is equal to change in kinetic energy कते गला हाफ एम भि स्क्वायर तले बर्तमान आमे देखिबा चार्जटा कोठी कोठी गला एठी ठीक गला त जदि आमे चार्जटा एठी ठीक नबा सपोज आमे बर्तमान एठी जदि if it displace if we bring the charge from q to this in a potential difference of v then how much work is done then work done to move the charge work done to move the charge work done to move the charge to move the charge from positive to negative electrode from positive to negative electrode from the positive to negative the work done to move the charge from positive to negative tale work done kete jibo tale w is equal to the potential difference kete achi v tale v charge ke q tale vq tale this is the equation 1 by etala vq tale work done kete gala vq tale we know the work energy principle the net work done is nothing but it is equal to the change in kinetic energy tale according to work energy principle work energy theorem tale according to work energy theorem the total work done is equal to change in kinetic energy yes tale that implies tale kon paile tale vq is equal to half m v square yeah tale this is the kinetic energy of kaharo of a charged particle if a charged particle moves in a potential moves koti the region where the potential difference is v tale tar kinetic energy kete jibo half m v square is equal to vq clear so this is the kinetic energy of a charged particle when it moves in a region where the potential difference is ketala v tale half m v square by kinetic energy kete gala tale kinetic energy is equal to q into v hala this is the kinetic energy clear tale bartan dekhiba tale what is the velocity tale if we find out tale velocity kete hobo tale v square is equal to 2 vq divided by m this is your velocity that implies the velocity of the charge when it is reaches at the negative tell how much velocity is acquired now vq divided by m clear hala tell this is the kinetic energy tell instead of a jadi if we consider for in case of an electron in a special case kara for an electron जदि हमें इलेक्ट्रॉन कथा देखिबा for an electron हला तले q केते ना q is equal to e for an electron तले बर्तन केते जिवो ना half m v square the kinetic energy of electron केते गेला e into v ev kinetic energy केते गेला ev by v square v केते जिवो so that implies v square is equal to by v केते गेला 2 e v by m ro rotavar hala 2 e v by m ro rotavar this is the velocity of electron when it is accelerates in a potential difference of a v volt hala so that is called velocity acquired by an electron केते गेला 2 e v by m this is the velocity, and this is your kinetic energy. Half mv square is equal to ev. Clear? তাহলে বর্তমান দেখিবা তাহলে if a charge, but if suppose an electron, মনে করো this is an এটা হলো two potential difference, এটা হলো positive plate and this is the negative conductor. This is the positive electrode, this is the negative electrode, and the potential difference between them is equal to, let it be V. V is the potential difference between these two electrodes. If it's an electron, যদি আমি গোটে ইলেকট্রনটাকে ধরতিবা তাহলে কোন হবে, electrons are accelerated towards what, a positive plate বা positive electrode, and when it reaches its velocity কেতে গেলা না v, it acquires a velocity v. তাহলে আর বর্তমান what is the kinetic energy? Now the kinetic energy kete gala half mv square is equal to ev, and this is known as aku kaja electron volt. Aku kaja electron volt. So what is the electron volt? The electron volt ela, it is the energy of an electron. It is the energy possessed by an electron when it is accelerated in a potential difference of kete gala 1 volt. But if an electron accelerates in a potential difference of 1 volt, then the energy of the electron is 1 electron volt. So we can write electron volt. Electron volt, what I short form like as EV. Electron volt. So it is the electrical energy. Electron volt, this is the energy. The electron volt, it is the energy acquired by an electron. So it is the energy acquired by an electron. Acquired by an electron. It is the energy acquired by an electron when it accelerates. When it accelerates, quoting in a potential difference of 1 volt. When in a potential difference of 1 volt. So when it is accelerates in a potential difference of 1 volt. ସେତେବେଳେ ତାର ଏନର୍ଜି ଟାକୁ ଆମେ କ'ଣ କହିବା, 1 ଇଲେକ୍ଟ୍ରନ୍ ଭୋଲ୍ଟ ବୋଲି କହିବା। ତାହେଲେ ଏନର୍ଜି ଇ ଇଜ ଇକ୍ୱାଲ କେତେ ଲେଖିଲି ନା 1 ଇଲେକ୍ଟ୍ରନ୍ ଭୋଲ୍ଟ ହେଲା। ତାହେଲେ 1 ଇଲେକ୍ଟ୍ରନ୍ ମିନ୍ସ ଆକୁ ଆମେ ଲେଖିପାରିବା 1.6 into 10 to the power minus 19 ହେଲା coulomb into 1 volt. So this is equal to 1.6 into 10 to the power minus 19 coulomb volt is equal to joule. This is the energy. So the energy acquired by an electron when it accelerates in a potential difference of 1 volt, ସେତେବେଳେ ତାର ଏନର୍ଜି ଯେତିକି ସେଟାକୁ ଆମେ କ'ଣ କହିବା 1 ଇଲେକ୍ଟ୍ରନ୍ ଭୋଲ୍ଟ ବୋଲି କହିବା। Then 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. Clear? This is your electron volt. So if I convert তাহলে এটা কত পাইলে, তাহলে 1.6 into 10 to the power minus 19 joule আগে আমি লিখি পারিবা ହେଲା বা 1.6 into 10 to the power minus 19 joule ହେଲା କେତେ 10.6 10 to the power 7 10 to the power 7 arc, but this is equal to 1.6 into 10 to the power minus কেতে গেল 12 arcs ହେଲା। So this is the electron volt. যদি কোয়া যায় what is the energy of an electron if it is accelerates in a potential difference of 2 volt, then yes we can say simple it is 2 electron volt. যদি এটা লইলা 2 volt then energy কেতে গেল 2 electron volt. যদি it is 3 volt then it is the 3 electron volt. Clear? তাহলে if an electron accelerates, তো লিখি পারিবা if an electron accelerates ହେଲା, if an electron accelerates in a potential difference of କେତେ ନେଲି 2 volt, if an electron accelerates in a potential difference of 2 volt, then what is the energy? Yes, then the energy, energy of electron, we say 2 electron volt. We say 2 electron volt. If it is the potential difference 3, then it is 3 electron volt. Clear? So this is the potential energy and your kinetic energy of the next one देखिए the dipole in an electric field, है dipole, potential energy of a dipole in an electric field, है तो potential energy of an electric dipole, potential energy of an electric dipole in a uniform electric field, the potential energy of an electric dipole in a uniform electric field. So if we place a dipole in a uniform electric field, suppose this is a uniform electric field. The uniform electric field, it is represented by the parallel lines of force. This is the parallel lines of force. Clear? So now we put a dipole here. So this is the dipole. This is the plus q and this is your minus q. Clear? So there is a force that exerts on the dipole, and this is the direction of the force, and this is on this dipole charge, this is the direction of the force. And these two forces are equal and opposite, but these two forces not acting in same line. Therefore, they exerts a torque on the dipole. Suppose this angle theta. Tale kon hobe ethi? They exerts a torque on the dipole. Suppose our dipole kete na p. Tale consider eta field ala ke E. Tale consider an electric dipole. Consider an electric dipole of dipole length, of a dipole moment कहते हैं ना p. Consider an electric dipole of a dipole moment p is placed where? Is placed in a uniform electric field, is placed in a uniform electric field कहते हैं E, placed in a uniform electric field E, and there is some angle theta, whatever may be, तला में कौन कले गोटे डाइपोल को नहीं कि हमें कौन करिबा फील्ड भीतर रखिबा. तल व्हाट हैपेंस? तल जेहेतु the field exerts equal and opposite force on the charge, therefore the resultant force on the dipole is 0. But these two forces are not in same direction. आगुरा में पढ़ी से तले they are not in same direction, they form a couple and exerts a torque on the dipole. तल what is the torque? The force into perpendicular distance. That is equal to हमें आगुरा पढ़ी थिले, that is equal to किते the p into e vector. हला तल तो the torque like a torque exerts on the dipole. A torque exerts on the dipole. Is given by that we already studied in electric field रे, a torque exerts on the dipole. कितने गला torque? Tau is equal to tau is equal to कितने गला? तो tau vector is equal to p vector cross e vector. Tau is equal to कितने गला? P vector cross e vector. This is the torque that exerts on the dipole. But we can magnitude में कौन लिख परिबा? Tau is equal to Pe sin theta. This is the torque that exerts on the dipole. हैला तले एबे हमें कोन करबा एटा लाइन मैग्नीट्यूड इन मैग्नीट्यूड तले टाउ इज pe sin theta क्लियर तो मने करो आम ये कौन कर सके पोटेंशियल एनर्जी ऑफ एन इलेक्ट्रिक डाइपोल प्लेस्ड इन ए यूनिफॉर्म इलेक्ट्रिक फील्ड पोटेंशियल एनर्जी कौन ताले पोटेंशियल एनर्जी ऑफ द डाइपोल इज नथिंग बट इट इज द अमाउंट ऑफ वर्क डन टू ब्रिंग ए डाइपोल फ्रॉम हो टू जीरो एनर्जी टू बा हला ताले मैं कौन करबा ताले पोटेंशियल एनर्जी कहले मैं कौन बजा जीरो एनर्जी पोजीशन अर्थात परपेंडिकुलर पोजीशन टू एनी डिजायर्ड पोजीशन को हमें वर्तमान कौन करबा शिफ्ट करबा ताले हाउ मच वर्क इज डन ताले केते वर्क डन हो जति वर्क डन हैला सेटाला तोर कोन पोटेंशियल एनर्जी ऑन द डाइपोल ताले लिखवा ताले सपोज हमें कौन कले हमें केते एंगल रोटेट करबा d थीटा हैला ताले टॉर्क हलाती ताले if dw be the work done if dw be the work done to rotate the dipole through a small angular displacement through a small angle kadela d theta through a small angle d theta then what is the dw then dw is equal to s tau d theta then that is equal to pe sin theta d theta this is the small work done to rotate the dipole through a small angle d theta clear तो लेबे में कौन करिबा the potential energy on a dipole in an electric field means it is the amount of work done to move the charge to rotate the dipole from zero energy position to any desired position. Suppose zero energy position, this is your zero energy position when the dipole is perpendicular. This is the zero energy position. Zero energy position. अर्थात when the dipole is perpendicular, then energy is zero. पर कोई भी this is your zero energy position. Zero energy position में कौन करिबा any desired position कहते हैं नहीं थीटा एंगल को टर्न करी तले how much work is done तले total work done हमें देखिबा तले total work done to rotate the dipole from zero energy position to any desired position the total work done to rotate the dipole from zero energy position to any desired position so dw integration 0 to w that is called integration pe sin theta d theta that is initial position k the zero energy position that is theta is equal to 90 degree then this is theta like period by alpha like period whatever may be so this is hala so now integrate here the dipole and field the dipole like 12q this is taking outside so 2pe taking outside or like the integration of sin theta d theta 90 to केते रहला थीटा क्लियर तले केते जे बैठे तले कोन बैठ देखो तले दैट इज इक्वल टू हला 2 कोड हला बे खाली पी ना हला और कोन थिला पी ना हला तले पी ई कोड छाड़ी गले की हां टाउ हला केते PE sin theta ठीक अछि ताले केते हला PE टेकिंग आउटसाइड PE और हला केते इंटीग्रेशन ऑफ sin theta that is equal to minus cos theta and limit varies from 0 to theta this is the work done clear ताले that is equal to केते गला minus PES cos upper value हला theta minus lower value हला 90 তাহলে cos 90 কেতে গেলা 0 তাহলে that is equal to minus PE cos theta তাহলে this is your work done हैला তাহলে this is the work done that is equal to minus PE cos theta and this is কোন হয়ে গেলা energy हैला रे this work done কোন কইবা আমি potential energy তাহলে so potential energy on the dipole potential energy on the dipole potential energy on the dipole কেতে গেলা U is equal to W that is equal to minus PE cos theta clear so this is the potential energy of the dipole when it is placed in an electric field U is equal to minus PE cos theta এবে দেখো when this is equal to 0 এটা cos theta কেতে 90 degree সেটাই কইতলা 90 degree when the dipole is placed 90 degree this is your zero energy position हैला তাহলে U is equal to minus PE cos theta this is the কোন পাইলে এটা energy potential energy on an electric dipole when it is placed in a uniform electric field so then देखिए special case special case प्रथम हला एकरे suppose the dipole is placed कोन लिखली along the তাহলে কেতে हला theta যদি dipole টা along the dipole रहिला field তাহলে theta केते हला 0 हला if the dipole is along E তাহলে কেতে গেলা রে theta is equal to 0 হলা তাহলে theta is equal to 0 if the dipole is along E তাহলে কেতে হইজটি theta is equal to 0 তাহলে P is equal to yes sorry U is equal to minus PE cos 0 that is equal to minus PE হলা minus P তাহলে if the dipole is along E vector along E vector then theta is equal to 0 U is equal to minus P cos 0 that is equal to minus P second if the dipole is perpendicular to E vector if the dipole is perpendicular to E vector yes if the dipole is perpendicular to E vector then theta কেতে গেলা তাহলে theta is equal to 90 degree the U is equal to minus PE cos 90 that is equal to 0 তাহলে কোন হয়ে গেলা when the dipole is perpendicular then it is a zero energy position then third one kon if the dipole is in opposite to E vector if the dipole is opposite to E vector if dipole is opposite to E vector if the dipole is opposite to E vector then theta kete gela 180 degree then theta is 180 degree theta is 180 degree then P kete U kete gela minus PE cos 180 that is equal to PE cos 180 minus 1 minus 1 minus 1 plus 1 clear তাহলে এটা আমি কোন জানলে দেখো তো এটি কোন পাইলে minus P potential energy এটি কোন পাইলে 0 এটা হলো P তাহলে this is the minimum value this is the maximum value and it is the zero position হলা তাহলে this is your minimum and this is the maximum এটা হলো minimum and this is your maximum হলা তাহলে which one is the minimum position তাহলে if the dipole is along the curve field হলা সেটা হলো minimum দেখো this is your electric field yes and we put a dipole along means this is the plus and this is the minus কারণ dipole moment is always along the direction negative to positive তাহলে in this case theta 0 and ako আমি কোন কইয়া minimum position minimum energy position and a minimum energy position তাহলে in this case the dipole is in a stable condition this is the stable condition where the energy is minimum that is known as the stable condition next I mean this is perpendicular this is E vector and this is the dipole moment এটা গেল কি plus q eta egala minus q. So this is the dipole vector perpendicular. So this is your zero energy position. Eta la zero energy position. Hala zero energy position. Now कहबा हमें neutral condition. eta egala neutral. Neutral condition. Neutral condition. Zero energy position. Next, जदि आमे देखिबा opposite. देखो opposite कौन होची? Suppose this is your opposite. Hela, this is the dipole. Yes, this is the dipole. Now we consider this side is plus q and this side is minus q. The dipole is moment this opposite direction. तल ए जगह रे कौन हबो? ए जगह रे कौन हबो? रिप हला तल एटा maximum energy position. Maximum energy hela position. Maximum energy position. Maximum energy position. हला तल ए जगह रे energy कते गेला? Maximum. এটা ইতলা minus p, এটা ইজ plus p. এটা হয়ে গেল 0 হলা এবং it is unstable condition. This is your unstable karan here energy is more. If a system has more energy then it is a unstable condition. Clear? This is the unstable condition, this is a stable condition and this is the neutral condition of the dipole when it is placed in a uniform electric field. Clear? Thank you.